Welcome to our talk on defense against on-chip Trojans that enable traffic analysis attacks in multi-core processors. This work is done in collaboration between three universities: Rochester Institute of Technology, George Mason University, and UT Dallas. Welcome to our talk. The motivation for our research is that modern systems on chips use third-party IPs or 3P IPs to reduce cost and time to market in the design cycle. Generally, multi-core systems on chips or processors are interconnected using a communication backbone called network on chip or NOC. Now these NOCs end up providing a very large surface area and vulnerability to insert hardware Trojans or launch hardware security type of attacks because they are such an important part of the design. Now, in our threat model, what we envision is that a hardware Trojan is inserted in this NOC-enabled multi-core processor where each of the blue blocks are cores, and what it does is it is able to monitor to a degree the traffic that is crossing the switch of the NOC that is infected with the hardware Trojan. Then this can send this traffic monitoring data to an external attacker, such as shown over here, that can analyze that information, maybe employing machine learning or advanced AI algorithms or data processing algorithms, to understand what applications are going on or launched or running in the system. Now this can have severe implications because once an attacker or an external agent figures out what applications are running on the system, that may be used to either compromise user privacy or launch further more severe attacks, especially if the system is deployed in a information sensitive environment such as military environment or avionics environment or banking sectors. Now we also propose a method to defend against such an attack, and the approach that we take here is to use a controlled random or dynamic routing based on a simulated annealing heuristics instead of a deterministic routing. While many adaptive routings have been proposed for various purposes in a NOC, mostly for a fault resilience purpose, here we adopt a simulated annealing kind of approach because that gives us a degree of controllability over how random the paths are. So now we can go into the result, and you can find more details about our simulation environment in the paper itself, which is published in AsianHOST2020. But this is our simulation framework, as you can see here, using a variety of simulation tools into the suite. But going directly into the results, what we see is that as we vary the parameter alpha, which controls how random the routing decisions are at each node, we see as alpha decreases, the more random the routing decisions get. This is the probability density function of the latencies of the packets. Whereas alpha decreases and the routing decisions are allowed to be more and more random, you can see that the average latency as well as the variance in the latency in the system increases. So going forward, what we see is the accuracy of the attacker when there are an increasing number of Trojans inserted in the system. This system we have considered is a 64-core processor with 16 DRAM memory controllers. So as you can see in the gray shaded bars, with 2 and 4 Trojans inserted in the system, the accuracy of the detection can be very high, almost 90%. With further increasing the number of Trojans to 8 and 16, it can increase, very close to 95%. Whereas now, with the random probability increasing, that is values of alpha reducing to 0.01 and 0.005, we see that the accuracy of that classification drops significantly to almost 15%, and then further with reducing alpha to 0.005, it reduces further to 10%. So we are able to obfuscate and confuse the ML attacker about what application is going on to a significant amount by simply adopting this simulated annealing based random routing. So one of the important things to note is that the hardware Trojan has a very small area of about 1500 square microns, which accounts for about 0.04% area of the switch, thereby making its silicon footprint very small, so small that it is easy for it to avoid detection. So in conclusion, we designed this very efficient hardware Trojan inserted into the NOC switches that can monitor and leak traffic patterns, and a sophisticated ML mechanism can be used to analyze this traffic and infer what application suites are running in the system, eventually leading to compromising user privacy. And we also showed that a controlled random simulated annealing based routing can be used to obfuscate this particular type of attack and can reduce the accuracy of the inference to 15% or lower from a very high accuracy of 90 or 95%. We want to thank you for listening to our talk, and we want to acknowledge our research sponsors, the US DARPA agency, for sponsoring our research on this topic. Thank you very much.